My name is Eren Kömürlü. I am from Turkey. My presentation title is High Density Polyurethane Rigid Foam Usability as Liner Support Material in Rock Engineering. Here is my content. Although the shotgrid has become a worldwide standard tunnel liner, it needs to be improved because of its lacks of having brittle material characteristics, low tensile strength values, late curing time, and rebound problems. To overcome the problems of shotgrid liners, different chemical additives and reinforcements are used in shotgrid mixes. However, the shotgrid liners still have many issues needing for significant improvements. For instance, shotgrid liners show early cracking while being deformed despite the use of different additives. Since 1990s, thermoset polymeric liners have started to be in use in mining industry as called thin spray-on liners. Because of the ability to solidify soon after spraying, polyurethane TSLs can carry load very early in comparison with the shotgrid liners. Load-bearing capacities of TSLs depend on both TSL material strength and their adhesion to the rock surfaces. TSL products are a good isolation material for rock masses. However, TSLs cannot be assessed economical to be used as alternative of shotgrid liners with a thickness with a high thickness like over 6 centimeter or higher. TSLs cannot be adequate for having a similar stiffness with that of the shotgrid liners. The support reactions of TSLs lie between those of steel meshes and shotgrids. As another problem of TSLs, spraying on rough surfaces may cause local decreases in significant change in the thin liner thicknesses. Therefore, TSL load-bearing capacity can be notably affected as a result of the uncontrollable inhomogeneity in the liner thickness. Instead of using polymeric TSLs with thicknesses of some millimeters, high-density polyurethane rigid foam products having similar thickness values with those of the shotgrid liners are investigated in this study to assess whether proper support performances can be supplied by eliminating the shotgrid disadvantages of brittle material characteristics, late curing time, and rebound problem. Additionally, good chemical resistivity of polyurethane materials, which is an advantage against the shotgrid liners, was another reason for investigating its usability in rock engineering. Methodology. In the study, both field and laboratory tests were performed. The names of the tests are seen on the screen now. Yes, we carried out the slab load tests, which is a very popular test to determine the support performances and load bearing capacities of the liner materials. Also, we have carried out the 3-point flexural strength tests. As I noted before, the adhesion performance to rock contact surfaces is another important parameter for liner materials. So the adhesion tests were carried out within this study, and the results have been obtained from this test. Also, universal compressive strength values of the PRF material has been carried out within the study. This is a picture from the uniaxial direct tensile strength test of the polyurethane rigid liner material, which is a high density PRF material. In this figures A part, you see now the stress strain behavior of this material under uniaxial compression situation, and the B section is for the uniaxial tensile strength test. It should be noted here and that a high density polyurethane rigid foam is used within this study. The polyurethane foams can be divided into three groups according to their densities, as light foams, mid-density foams, and dense foams. The dense foams have a higher density than 180 kilogram per cubic meter. If a polyurethane rigid foam has a higher density than that value, we can say the dense foams for that product. So the mechanical properties also depends on the density of these polyurethane foam products. In the study, a foam product with a density of 180 kilogram per cubic meter is used. In the field study, spring application of the PRF liner was found to be practical and have no rebound problem. Because of the rapid polymerization, PRF liner started to float as it sprayed on the wall. As a result of its frothing, much lower amount of material used in comparison with the shotgun amounts was seen to be enough in PRF applications. As a significant advantage of PRF liners, rock bolting can be done directly after liner application without a need for waiting curing reactions, in contrast to the use of shotgrit. In the pilot PRF liner study, just a couple of minutes after PRF spraying was determined enough for start of rock bolting. For lighting performance in tunneling, white color of PRF liners was seen to be another advantage. Because of very limited time of the symposium presentations, I would not able to give a very detailed information about our numerical studies, but I should add that also some numerical analyses have been carried out to investigate the usability of the PRF liners, rigid high density PRF liners in rock engineering, and some according to the our results, we found that according to the both experimental and numerical analysis, PRF liners were found to have enough load bearing capacity. However, low stiffness values of PRF liners are notable for unsuitability to use instead of thick shotgrit liners. On the other hand, its practical application and fast curing time can supply earlier support pressure in comparison with shotgrit liners. Because of its ductile material characteristics, PRF liners have a good energy absorbing capacity, which makes the liner supports advantageous against the dynamic loading. PRF material has significantly higher energy absorbing capacity in comparison with the shotgrit materials. Therefore, use of the PRF liners is profitable to combat the rock burst problem. In addition, its high deformation limits make PRF liners to be usable in rock masses with skewing and clay swelling problems. Its good energy absorbing capacity and rapid polymerization are also advantageous for eliminating the fresh liner cracks induced due to the blasting operations. In addition to the body strength of the liner material, their adhesion performances have a great importance for the support reactions and the load bearing capacity. As obtained from the study, the PRF liner material has proper adhesion to rock values. Using no aggregates in the PRF liners is a significant advantage in terms of having a good adhesion performance. Tensile strength values of PRF specimens were found to be in the same class with that of the shotcrete materials. Even though the load-bearing performance of the PRF liners was found to be lower than the shotcrete liners, its load-bearing capacity is notable in terms of supplying stability against the potential rockfalls. Stiffness values of the PRF liners are significantly lower than those of the shotcrete liners. This situation means that PRF liners are not preferable for poor rock masses, which need for the use of stiff supports. It should be noted here that the PRF liner material are evaluated for its potential use as an alternative of thin primer shotcrete liners, not permanent concrete supports such as concrete liners in tunneling. A rigid polyurethane foam product was tested in the study. For higher support pressures, a different pair of materials with higher densities than that of the product used in the study is open to be tested for suggesting a better liner material. According to the results obtained from the study, sufficient support pressures can be supplied by using high-density PRF liners. However, it should be again noted that their low stiffness values make the support reactions of the PRF liners differ from those of the typical shotcrete liners. Their ductility and high energy absorption capacity values are notable advantages to use PRF liners in different rock masses. Increase in number of PRF liner application sites has a great potential to gain high rate by new investigations on its systematic use and better understanding its support properties. Thank you for your interest.